Okay, so let's get started. So the plan for today is March 26th. So today, the topics that we are planning to go over, trig function and implicit differentiation. Next time, Wednesday, we'll do mean value theorem. Also, the plan for the day is I'm going to return you test at the end of the class. I'll return you test. So let's start with the problem. Limit as x goes to 0, 1 minus cosine x over x. I want you to try it for 10 seconds or 20 seconds and report me your finding. I want you to investigate that. I want everyone to investigate this function. Meanwhile, hopefully, most of the students will show. Yeah. Say it again. Okay. Okay. Undefined. Okay. We'll wait for other people. Undefined. Okay. Okay. We'll definitely. We'll definitely wait for other people's opinion. Anybody else? What is what is the result? Someone said he said undefined.
Yeah.
You agree with him?
Yeah.
Undefined. Okay. So Fatima, I agree with him.
Okay.
You agree with him? Okay. So we go by popular opinion, right? Most of the people think undefined, so it should be undefined, right? Yeah. Is 1. Oh, someone said 1. Someone said 1. Okay. Anything else? Okay. We almost have the half of the class. We are trying to understand. We are trying to investigate the streak. And people are saying that undefined, 1 and something else. Anybody have any new idea? Okay, so it's not undefined and it's not 1. And let's check why it is not. So limit as x goes to 0, 1 minus cosine x over x, multiply by conjugate. What is the conjugate? 1 plus cosine x and then over x? Over what? Over x or something else?
Cos is plus cos is 1 plus cos x.
That's right. 1 plus cosine x. You just cannot write x downstairs because now as if you did nothing, as if you multiply the function with 1. So let's do some algebra. 1 times 1 is how much?
1.
1. 1 times cosine x is?
Cosine
minus cosine x times 1 is
Negative cosine x.
negative cosine x. Negative and positive
Negative cosine squared x.
cosine squared x. Okay, that's on the top. What should be on the bottom?
X plus x cosine squared cos squared.
Okay, so limit as x goes to 0. Can we cancel these two?
Yeah.
So 1 plus cosine square x over x, 1 plus cosine x.
Can it be minus cosine squared x?
1 minus cosine square x because this is minus. Very nice. Very nice. Okay. 1 minus cosine x, 1 minus cosine square x is sine square x. So can I write sine square x? Can I replace 1 minus cosine square x by sine square x?
Yeah.
Because sine square x plus cosine square x equal to 1. So then sine square x is equal to 1 minus cosine square x. For that reason we can do that. So x, 1 plus cosine x. We're almost done. Now we're going to divide and conquer. Limit as x goes to 0. Sine square x over x. Sine square x over x. Just write sine x over x. And then limit as x goes to 0. What should we write? Sine x over 1 plus cosine x. This one is 1. Raise hand if you understand this one, why this one is 1. Raise hand if you don't understand. If only 3 people did not raise hand. Or only 3 people raise hand. Everyone else understand why this one is 1? Why this one is 1?
Because if you put 0 and then it equals to 1. So if you put 0,
How can this be 1?
also 0 divided by 0 equal to 1.
0
Divide by 0.
divided by 0 is 1? So how can, why did I write 1 here? So I thought you understood it. That's what
X in the denominator goes to 0. If it goes to 0, it
so
will
0
be
over 0 is undefined. Why did I write 1? What allowed me to write 1?
X divided by x.
No,
Goes to infinity.
we are supposed to know that it's like
We are supposed to know that. Okay.
define like rules.
Remember me again.
Okay, so this is called
Identical.
squeeze theorem. Squeeze theorem. Squeeze theorem allows us to write limit as x goes to 0, sine x over x is 1.
So what is the squeeze theorem? Like what is it? What is the squeeze theorem?
Okay, let me finish it, then I'll explain the squeeze theorem.
Okay.
Let's just take it for granted now. Well, just believe it. Believe it that it is 1, and then once we finish this, we will discuss the squeeze theorem for a second. So limit, yes.
Just one thing. You start like 1 minus cosine x in the beginning.
Yeah.
Over x.
Yeah.
And how you get how the next step? What happened there?
He multiplied by
This is line 1, line 2, line 3, line 4, line 5. Which line you have a problem with?
Line 1.
Line 1 have a problem. Okay, can someone explain?
Please.
Yes.
You multiplied by what's the equivalent of 1 to transform it into a more manipulatable format.
This is called conjugate. I multiply it by conjugate.
By the
Conjugate. Conjugate means
The inverse of.
not,
It is a inverse.
it's opposite sign.
Yeah, inverse.
Okay.
okay.
This is called conjugate.
Right, okay.
Did you understand line number 1?
Yes, basically, yeah.
So limit as x goes to 0, limit as x goes to 0, this one is 0, this one is, so this one is 0, right? Because sine, this is when cosine 0 degree is 1 and sine 0 degree is 0. So then what do you get? 0 over what? 1 plus cosine 0 degree is 1. So 0 over 2, which is 0. Does that make sense? So 1 times 0, which is 0. So limit as x goes to 0, I'll explain this quiz theorem. I'll explain it in a second. Limit as x goes to 0, 1 minus cosine x over x is 0. However, if you do write 0 in the test, that will not be quotient. You have to prove that. Just like in the test, when I ask you, show that the derivative of tangent x is equal to secant square x. Okay. All right. Now, anything you don't understand before I explain this quiz theorem? Yeah.
X over 1 plus cosine x. I don't know why did you choose only.
Say it again, Fatima. Say it again.
Sine x over 1 plus, yeah, this one. The way from 0. I don't know why did you choose like only 1x. I don't know. I didn't understand that part. How did you-
Sine x is sine 0, right? And sine 0 is what?
Oh, okay, you plug in x.
Right. Sine 0 degree is by definition, you can write it. Sine 0 degree is by definition 0. Sine 0 degree is by definition. If you apply physics, then you will understand it better. For example, cosine. Cosine 0 degree, meaning that you apply the force. All the force are acting at the x direction. No force is acting at the y direction. So if I push this with 10 Newton, for example, with 10 Newton, how much force is acting at the x direction? And how much force is acting in the y direction? What about now?
Y direction is,
Okay, it's better than angle.
This is 45 degrees, so half x and half y. So that's where that's how you can understand it. So it's quiz theorem. So if x is not a, and if limit x goes to a of g of x, another condition, if g of x is less than equal to f of x, which is less than equal to h of x, then and if x goes to a, g of x is equal to limit x goes to a, h of x is equal to L, then limit x goes to a, f of x is also L. So I will, how many of you understood this one? Raise hand. Only one people.
No, okay.
I'll give you some intuitive example. Okay, say Albert, represented by g of x, Isaac, represented by f of x, and say Dad, represented by h of x. Now let's write three statements. Isaac read more than Albert, and Dad read more than more than Isaac. Then Isaac is in the middle, right? So Isaac read less than who? That, or less than or equal to. And more than who? More than or equal to? Albert. That's what exactly I wrote over here. So Isaac is in the middle, so f of x is in the middle. H of x. And this one? G of x. You can show it by graph. If this is your graph, this is your A, and this is your R. So A cannot be, X cannot be A. X cannot be A. That means X can approach to A, but X can never be at A. X can approach from the right side and from the left side. Okay.
The limit is
Say it again.
A. The limit is
A is a number. X can approach to
A. What can,
A.
what can it be?
Say it again.
Can approach to A, but cannot.
If it is at A, then it would give us a problem like 0 over 0 type of problem, which we explored before, right?
That's what he was asking is if A was a limit. That's what he was asking. A is a limit.
If A is a
limit.
if A is a limit,
Yeah.
okay, then what?
No, that's what I mean. If can be near A, but can't be A.
If X cannot be at A, yeah, X cannot be at A. X can be very close to A. If A is a number, let's say 2. X can be, if you come from negative side, how close you can be? 1.999999, as many 9 as you want.
I think you said the wrong thing. It's not a limit. It's an
But not being
Hmm?
Sorry, I think you said the wrong thing. It's not a limit. It's an asymptote.
That's, we are talking about then approaching to the infinity. When it is infinity, then we talk about asymptotes. There is no asymptotes here now. When x goes to limit, as x goes to infinity, 1 over x, then we are talking about asymptotes. Okay? All right. So if you come from the positive side, what should it be? How close you can be? 2 points. As many zeros as, but you cannot write 2. Okay, so that's what I mean. But why 2 should be why 2 should be special? Instead of 2, we can put what? Instead of 2, what can we put? A. No, not H. H means it's totally different thing. H is used for, say, this is limit definition. Limit H goes to 0. H goes to 0 means if this is your function, say P of t is 40 over 3 t squared. This is your x. This is your x plus h. Then this is your x. This is your x plus h. H goes to 0 means what? Difference between this one and this one is almost nothing. Almost nothing, but not nothing. Almost nothing. Very close. So if h is very close, then if this one is 2, then this one should be 2.000, as many 0 as you like. And then you can put 1. Does that make sense? Okay, let's go back over there. Okay, so Squeeze theorem tells us that this is A, this is A. So let's draw something. Let's call this one Albert. I'm going to replace by notation in a second. Once you get the hang of it. Let's call this, what should I call this one? Dad. Then Isaac has no choice. Isaac has to be between squeeze. Isaac is squeezed. Isaac can do all the thing, but he has to be squeezed to Dad and Albert. So this is Isaac. So I'm going to replace those name by notation because you have to eventually deal with notation. So Dad, who takes place of Dad? H of x. And this one? G of x. And this one? F of x. So, but this analogy hopefully kind of, in the long run, you probably will not remember that one. But hopefully in the long run, you remember this Isaac Albert thing. So, I can quickly show you a visual proof of x over sin x over x. But if you understand it, I can move on. Did you understand it, or you want to see a visual proof? Okay. A visual proof. So visual proof. Visual proof. Proof of squeeze theorem. Visual proof of squeeze theorem. Let's draw a unit circle. Unit circle has how many quadrants?
4.
Okay, we can divide it in 4 quadrants. Okay. Let's draw a line. Let it go outside the unit circle. Let it go outside the unit circle. Let's join these 2 points. And let's join these 2 points. Okay. Do you see that? Okay. This is an angle. What should we call angle? It's a convention to call it theta, but let's call it x. It's also convention to call it x. All right. So we can write that analogy. What analogy did I use? Albert. So I'm going to use that analogy. So visual proof is to help you understand, not to because this is not proof plus. You are not responsible. Proof is not going to be in the test. So I'm going to use that analogy. So Isaac is between who? Okay. So that means this is g of x. This is less than f of x. This is less than h of x. Alright, I did not put greater than or equal to. Just keep it visual. Let's find the area of this one. Let's find the area of this guy. This guy. I'm gonna zoom in so that you'll see that what I'm trying to say. So I have a whole circle, but our main focus is here. So I'm trying to take the area of this guy, the area of this guy, the area of this guy. Which one should that fall under? Albert, Isaac, or Dad? Huh?
I would say the middle value. F of x.
First, draw Isaac on the middle first. You know.
No, the smaller triangle. The area of a smaller triangle, who said g of x? Okay, yeah, g of x. So g of x. What is the area of a triangle? Can someone tell me? Half bh. In the unit circle, whether we did it on the first class or second class, in the unit circle, the radius is, what is the radius? Radius of the unit circle is what? 1. Good. 1. So 1. What do you call the y? What do you call y? There is, okay, so you have a circle, right? You have a value, say you have 1, 0, right? You have 45 degree, you have the square root of 2 over 2, comma square root of 2 over 2. This is called x, this is called y. However, also you can call this one is this one is cosine, this one is sine. Alright. So the height, the y is, this is x, this is y. So the y is sine. Okay, y is sine. So y is sine x, and x is cosine x. So can we replace by x or y? Y, because height is the vertical, and that should be sine x. Now let's take the area in the middle one. Area in the middle one, we also know the area of that one. We did it before on the second class or third class. The area when you have the arc. So this is the arc. So this is the arc. If you include that, then what should it be? X over, x is the angle, x over 2 pi times pi r square. Let's do the last one. H of x, which is the last one. Last one is this one, the bigger one.
Professor, that second one you just did, what I don't get the formula for that. What is that? RQ computed?
So theta, this is the theta. This is this angle, right? This angle is how much? Theta. With this angle is how much? This angle is 2 pi times. I'm trying to take the area of that one. What is the area? Pi r square. Okay. The last one is half bh. What is the b? What is the radius here? 1. The radius is 1. And the h is tangent theta. It's not obvious probably. Let's make it obvious. Tangent theta is what? Tangent theta is opposite over? No, not hypotenuse. Opposite over adjacent. So tangent theta is opposite. Adjacent is, we claim that adjacent is what? 1. So opposite is then what? Tangent. Opposite is tangent. So we can write that tangent. Alright, now we almost done. Now this is the kind of understanding part. Now rest of them is easy. Now pi cancel. What are you going to do? Can we multiply everything by 2?
Yeah.
2, 2, 2. If you do multiply everything by 2, you get sine x, x over 2,
No.
just x, just x itself.
Squared,
Very nice.
x r squared.
And tangent x. All right.
Why is r squared?
Setting r square, 1 square. Very nice. 1 square. Is that okay? Radius is 1 square. So r is gone. Does that make sense? This inequality makes sense? Okay, so we have an inequality. So once we have an inequality, we just take the absolute value of the inequality. So it does not only hold for first quadrant, it holds for the other quadrant. So we take the absolute value. Let's divide everything by sin x. Sin x. Sin x. Sin x. If we do divide everything by sin x, what do we got on the left side? 1. What do we get in the middle? Absolute value of x over absolute value of sine of x. And then what do you get here? 1 over cosine. 1 over cosine x. Is that okay? 1 over cosine x. Now we're going to invert it. You're going to invert it. Inverting it. When you invert inequality, you flip the sign. Let's say this is 1 over 1. You invert it. If you flip 1 over 1, what do you get? 1. Since it is inequality, you invert the sign. So then sine x over x. And then what do you get? Cosine x. Cosine x. Now I'm going to sloppily write limit. I ran out of time. Limit x goes to 0. If limit x goes to 0, then what is the limit of 1? If limit x goes to 0, what is it? 1. And if limit x goes to 0, what is the limit of cosine x? 1. Cosine 0 is 1. So if limit, okay, so we can say this is 1 by squeeze theorem, by squeeze theorem, which is g of x if now it will make more sense hopefully. If g of x or those statements you can write it again. X cannot be if x is not a, and g of x is, f of x is less than h of x. And if limit x goes to, in this case 0, g of x is 1. And limit x goes to 0. In this case we are not using a because a replaced by 0. H of x is, this is Albert, this is dad. 1. Then Isaac is, x goes to 0. The Isaac, f of x is 1. Huh? No, this is not going to be, never going to be in the exam. Okay, so now I'll give you some squeeze theorem problem. Hopefully you will be able to solve them now. Solve this problem. 3x. I'll give you 10 seconds.
Okay.
Yeah, more than 10 seconds. X cubed plus 2. Find f of x as x goes to 1. Do this one. Let me write few more over there.
Find limit or find x?
Find limit as find f of find f of x as limit as x goes to x goes to 1. Let's write more. This is number 1. You can try to solve that one. I'm going to write more. F of x is the Isaac. This is Isaac. This is Albert. This is Dad.
No, the limit is just the function that we have to count, or the limit of the function.
It's three.
This is limit x goes to 1. 3x is what? 3. Limit x goes to
X,
x goes to 1.
or X.
X cubed plus 2 is
Three.
also 3. So
F of x is
So that means
So,
I'm equation.
so limit as x goes to 1, f of x must be 3 by the squeeze theorem, which you have to mention. And I will not mention it again. Which you have to mention, okay? Say it again?
10 points.
Yeah.
I was confused because you said found f of x, not limit of x.
This is f of x, and limit I gave you this one. This implies to here, here, and here.
Find f of x.
Find f of x, limit x goes to 1. Of this one, I can write it more explicitly. So I can write it, this one I write it more explicitly then. Find limit as x goes to 0, x squared cosine 1 over x squared. Do this one. I'll write a few more. I'll write it over there. So try to do this one while I finish writing some problem over here.
Using the same.
Use the squeeze theorem. Find limit x goes to 1 given 4 f of x squared plus 6x minus 3. This is number 3. Number 4, limit x goes to 0, x4 sine 3 over x. 5. Um, 8 minus limit x goes to 0, 8 minus x cubed f of x limit x goes to 0, limit x goes to 0, 8 plus x cubed. Limit x goes to 0, x sine x. Limit x goes to 0, x cubed cosine 1 over x. Okay, I think that's enough. Did anyone solve this one?
I think it's 0.
0, okay. Alright, so I'll give you a hint. The cosine 1 over x squared is in the, it has an upper and lower. So the cosine, say it again. You said answer is 0? I don't know. We'll find out. How many people have the answer? 1? 1, okay. Anybody else?
He said y from
Y from negative 1 to 1? Y is from negative 1 to 1?
Yeah.
The trig function, this is sine. So this is 1, this is negative 1. So this amplitude is negative 1 to 1. So we multiply, we have to multiply it with a number, with a with a quantity that is interesting for us. What quantity is interesting for us? Is it x cubed, z cubed,
X squared.
x squared? X squared is the interested quantity for us. We have to write x squared here again. Why x squared is an interesting quantity for us? Because now the middle guy look like the function that I gave you. So x squared, so now you take the limit as x goes to 0, negative x squared, or you can bring negative here, is what? 0. X squared cosine 1 over x squared. I think someone says 0. Okay. Limit as x goes to 0, this is also 0. Then this one must be 0 by squeeze theorem. That is, write all the notation. That is limit x goes to 0, x squared is 0, and limit x goes to 0, the x squared is 0, not x squared, yeah, this is negative x squared, this is positive x squared. So limit x goes to 0, x squared cosine 1 over x squared is 0. Please make sure you do write all of the argument in the test, or make it seem obvious.
I still don't
You still don't understand? What part you don't understand?
like, for example, what I did, you know, this x approaching 0. I did it in a way that I can put make x 0. And they give me.
If the lower limit is 0 and the upper limit is 0, then that's the squeeze theorem. Understanding has to come from the theorem, not the problem. If you do not apply the theorem, you cannot understand the problem. And the understanding has to come from theorem. X cannot be a, and g of x, f of x, h of x, if limit as x goes to a, g of x is L, and limit x goes to a, h of x is L, then limit x goes to a, f of x has to be, there is no other choice. Now replace the notation. X goes to what? 0. Say this one is 0. And x goes to 0, this one is 0. Then x goes to 0, this one must be 0. There is no other, this is by squeeze theorem. And go over the visual proof at home if that kind of helps you understand it. This problem, how many I give you? This for the homework. 1, 2. You want me to solve one more or?
Yeah.
Okay, which one you want me to solve?
3.
Number 3. Which one is 3?
It's like 4 than this one.
No, do the.
Do number 4. 4 over there.
Number
Yeah.
3 is over there.
4. That 4.
3 is easy.
4. Okay, I'll do 4. And remaining is 4 and anything else before I. 3 and 4. Okay, 3 and 4. That's it. 3 and 4. And everything else is homework. Okay. I'm erasing it because this will be homework. Okay. 3 and 4. Can someone give me 3? Oh, 3 is there. Find a limit as x goes to 1 given x goes to 1 implies all 3 inequality. 4 less than equal to f of x squared plus 6x minus 3. So limit as x goes to 1, limit as x goes to 1 of 4 is
4.
limit as x goes to 1 of f of x is limit as x goes to 1 of x squared plus 6x minus 3 has to be, let's see, is it 4? 1 plus 6 minus 3, so 7 minus 3, which is 4. 4, okay, so 4. Then we're gonna write limit x goes to 1, limit as x goes to 1 is what?
4.
Is 4. Limit as x goes to 1, this quantity is also 4 because it is squeezed by these other two quantities. Does that make sense? Or you can write like that. This is also 4 by squeeze theorem. Theorem, which is limit x goes to 1 of 4 is 4. Limit as x goes to 1 f of x is also 4 because limit upper limit and lower limit both goes to 4 as x goes to 1. 4. And which number you asked to solve it? 4. Okay, 4 is just like this one, trigonometry. Minus 1 and plus 1. Say it again.
The homework is 4, 5, and which one is the other one?
Oh, 6, 7.
Okay.
6, 7.
What is the sign and the number 5? What do you write? SI next to
8 minus x cube less than equal to
and 8 plus x cube.
limit x goes to 0. Just limit x goes to 0. On the left side, 8 minus x cube. On the right side, 8 plus x cube. Okay, so let's do this one and then we move to our second topic. What is the problem? Limit x goes to 0, x4 sine 3 over x. Alright, so sine 3 over x, this is sine. Just like the cosine, the sine is bounded by?
Minus 1 plus.
Sine is bounded by minus 1 and plus 1. That's right? The point of interest before was x squared. This time the point of interest is what? X to the 4. So negative 1 x to the 4. Negative 1 x to the 4. And then what? And no. x4 sine 3 over x 1 x4. Now limit as x goes to what? As goes to 0. Then this is what? Minus x4 is 0. Limit as x goes to 0. x4 sine 3 over x. Limit as x goes to 0. x4 is 0. So this is 0 by by this quiz theorem, which you will write it. Not writing it again. Okay. So now we will do something called implicit differentiation. So this quiz theorem, I was planning to do this quiz theorem on Wednesday. I couldn't do it.
You said if we write last week, then we got to write the whole statement.
You do, but you don't have to never have to do the proof. Yeah, proof. I did a visual proof, not the real one. I just use the analogy to show you a greater understanding. So implicit differentiation. Implicit. So far we differentiate function with respect to y as a function of x. For example, y equal to x squared. You can differentiate it by how? Y prime is equal to 2x. If I ask you to take a tangent line when x is 2, if I ask you to find the equation for a tangent line when x is 2, you can do it, right? It's pretty easy, right? Now we're going to do something different, which is called implicit differentiation. So, for example, I ask you to determine y by this equation. Y4 plus xy x cubed minus x plus 2, and I can draw it. And if I ask you to find the tangent line, over here, when x is 2, you can easily find it, right? What do you have to do to find the tangent line? So f prime of 2 is equal to what? 4, right? F prime of 2 is equal to 4. And what is your x comma y? What is your x comma y? Say it again?
You said f prime of 2 is equal to 4. I was paying attention. I was writing.
Because 2 times 2 times 2 is 4. X is 2. If x is 2, what is y? What is y? If x is 2,
Y is 4.
y is 4. So what is the slope of this line? 4. And what is the tangent line? So y is equal to m is 4, x1 is 2, y1 is 4. So y is equal to 4x minus 8 plus 4. So y is equal to 4x minus 4. So y equal to 4x minus 4. This would be what? This would be the equation of function or equation of tangent line? Equation of tangent line. What about the equation of function? X squared. Okay, that's good. What about this one? What is the problem here? So there is a problem, and we will use the different technique for this problem. We cannot do it explicitly. We did it explicitly. Now we have to do it implicitly. So let's give you a problem. X squared plus y squared is equal to 1. Find equation of tangent line equation of tangent line when x is 3 over 5. 3 over 5. Equation of the tangent line when x is 3 over 5. Okay, let's first draw it. How is supposed to? This is something we know, right? X squared plus y squared equal to 1. This is something we know. What is this? This is a unit circle. This is a unit circle. What makes it a unit circle? 1 makes it a unit circle, right? If I put it r square, then it's a circle. Then it's a circle. If I put it 1, then this is a unit circle. All right. Y prime. Y prime. We already familiar with the y prime notation, right? Y prime is equivalent to. What about y? Y is equivalent to f of x, right? That's the same thing, right? Y prime is equivalent to dy dx. So you can write it down. Y prime is equal to dy dx, and we'll start using it today. So d dx is x squared plus d dx is y squared is equal to d dx is 1.
What did you mean?
We are meaning that we have to take the derivative of this one with respect to x. So let's take the derivative of y with respect to x. So dy dx is what? 2x. Okay, 2x. Very nice. 2x. Now here's the problem. This one, take the derivative of y with respect to x. Now this one, take the derivative of y with respect to x? No.
The expression, but there is no x, so it's a constant, no?
So we will try. We'll take it. We'll take it using a technique called implicit differentiation. So we're gonna write plus. We're gonna write 2y. We're gonna write dy dx. What is the derivative of a constant? Yeah, derivative of constant is 0. So we're gonna keep dy dx on the left side and send everything to the right side. So 2y dy dx is equal to minus 2x.
So, Professor, how did you get 2y by dx?
So you take the derivative of this one, right? So this is not, you are not taking the derivative of y with respect to x, right? So that's why you have to keep this notation. So 2x, okay, so dy dx is minus 2x over 2y. Yeah.
Sorry, this technique that you're using, what's the name?
That's the formula of negative derivative of second. What happened with the y? Why disappear?
Okay, yeah. And every time I did it, you hear follow him. Really? I thought you were one of the ones that understanding.
So you need the derivative of y first and put up the derivative equals x. So we add the original derivative for y. So we keep it as the dy. It's just when it
First line is the derivative of
by dx means positive. dy is positive. But in the sign of x that is anything has x belongs and only derivative for x. So, we only can derivative for x. That means the result of x. So anything, if I have x over here, I can do this. So I have x over here, so I take the derivative for x over here. That's the and this is the same thing. So, that's part of the 2x.
Sorry.